Have you ever looked in a mirror and wondered if there was another you on the other side, living an opposite existence? Well, the universe has its own mirror image, and it's called antimatter. It sounds like science fiction, but antimatter is very real. It's essentially matter's evil twin, particles with the same mass but opposite charge. When matter and antimatter meet, they annihilate each other in a burst of pure energy. The most efficient explosion the universe knows. But here's the really mind-blowing part. According to our best understanding of physics, the Big Bang should have created equal amounts of matter and antimatter. So where did all the antimatter go? Why is our universe overwhelmingly made of matter? In this video, we're diving deep into the bizarre world of antimatter. We'll explore what it is, how it's created, why it's so dangerous, and, most importantly, why its scarcity is one of the biggest mysteries in modern physics. Get ready to explore the universe's mirror image and unlock some of its deepest secrets. The story of antimatter isn't just a scientific discovery. It's a journey through some of the most brilliant minds in physics. It all starts conceptually with Paul Dirac. In 1928, Dirac was working on reconciling quantum mechanics with Einstein's theory of special relativity. He developed an equation that elegantly described the behavior of electrons. But it had a bizarre side effect. It predicted the existence of particles with the same mass as electrons, but with a positive charge. These weren't just theoretical oddities. Dirac boldly proposed they were real. Fast forward to 1932. Carl Anderson, while studying cosmic rays at Caltech, observed a particle with the same mass as an electron but curving in the opposite direction in a magnetic field. He had discovered the positron, the antimatter counterpart of the electron, and Dirac's prediction was triumphantly confirmed. The discovery of the positron opened up a whole new realm of possibilities. Scientists began to wonder if every particle had an antimatter twin. It wasn't long before the antiproton and antineutron were experimentally confirmed in the 1950s, solidifying the concept of antimatter as a fundamental part of the universe. But the story doesn't end there. Creating and studying antimatter is incredibly challenging. It requires enormous amounts of energy and sophisticated particle accelerators. Organizations like CERN have been instrumental in pushing the boundaries of antimatter research, allowing us to create and study antihydrogen, the antimatter equivalent of hydrogen, and explore the subtle differences between matter and antimatter. This ongoing research continues to unlock the secrets of our universe and helps us grapple with one of its biggest mysteries. Why is there so much more matter than antimatter? So, where does all this antimatter weirdness actually matter to us today? Turns out, it's not just theoretical physics anymore. One of the most impactful applications is in medicine, specifically with positron emission tomography, or PET scans. These scans use radioactive tracers that emit positrons, antimatter versions of electrons. When a positron meets an electron in the body, they annihilate, releasing energy in the form of gamma rays. These gamma rays are detected, allowing doctors to create incredibly detailed images of organs and tissues. helping diagnose cancers, heart problems, and brain disorders much earlier and more accurately than ever before. Beyond medicine, antimatter research is pushing the boundaries of fundamental physics. By carefully studying antimatter, scientists hope to unlock more secrets about the early universe and why there's so much more matter than antimatter today. Experiments at places like CERN are constantly refining our understanding of these fundamental forces. While harnessing antimatter as a fuel source, like in science fiction, is still a distant dream due to the challenges of production and storage, research continues. Even small amounts of antimatter could potentially provide incredibly efficient energy, revolutionizing space travel and other energy-intensive applications. Someday. So, from saving lives with PET scans to potentially powering future space exploration, antimatter might be rare and mysterious, but it's already having a very real impact on our lives and the future of science. So, to recap, antimatter is essentially matter's twin, possessing the same mass but with opposite charge. When they meet, annihilation occurs, releasing pure energy in a spectacular display. And while the Big Bang should have created equal amounts of matter and antimatter, our universe is overwhelmingly dominated by matter, a mystery scientists are still working tirelessly to solve. Unlocking the secrets of antimatter could revolutionize energy production, propulsion systems, and even medical imaging. The possibilities are mind-blowing. Hopefully, this video has shed some light on this fascinating topic. If you enjoyed learning about antimatter and its role in the universe, be sure to hit that like button and subscribe to the channel for more mind-expanding explorations of matter and energy. We've got plenty more planned, so stay tuned.